Hello everyone, welcome to my channel. Are you confused with what to study for CBSE exam from solution chapter? Then this video is for you. In this video, we will cover all the key scoring concepts from solution with some PYQs. Okay, so from this chapter, you can expect 7 marks. Okay, for your CBSE exam, you can expect 7 marks from this chapter. So we'll discuss scoring concepts. Okay, so first concept is concentration terms. First topic is concentration terms. Okay, under concentration terms, first important topic is molarity and molality. Molarity and molality. What is molarity? Molarity will denoted by capital M. Molality will denoted by small m. Okay. So from this, definition is important. So definition of molarity, what you will write? It is defined as number of moles of solute present in 1 liter of solution. Molarity is defined as number of moles of solute present in 1 liter of solution. Molality means number of moles of solute present in 1 kg of solvent. Okay, so the difference between molarity and molality, here we are using 1 liter of solution, here we are taking 1 kg of solvent. Okay, definitions are very important. Then comes to the formula. Formula for molarity, that is capital M is equal to W2 into 1000 divided by M2 into volume in ml. Okay, this is the formula for molarity. So this formula is very important. Based on these problems, they will ask. W2 means mass of solute. Okay, M2 means molar mass of solute. V is volume of solution. If volume is there in liter, then no need to write 1000 here. Okay, then next for molality, that is small letter m. So m is equal to W2 into 1000 divided by M2 into W1 in gram. Okay, so here the difference is, this is in volume, this is in weight, that is weight of solvent. W1 means weight of solvent, W2 means weight of solute, M2 means molar mass of solute. Okay, then unit for molarity is mole per liter. Unit for molality is mole per kg. Okay, so here mole per liter, here mole per kg. So remember this one. The next point, it is related to temperature. How it is related to temperature? So this molarity is, it is dependent on temperature. It is dependent on temperature. Why it is dependent on temperature? Because it related to molarity is related to volume. This volume will change with temperature. So molarity also will change with temperature. So this molarity is inversely proportional to temperature. Remember this one. How it is related to temperature? It is inversely proportional to temperature. If temperature is increases, volume also increase. Okay, temperature is increases means volume of the solution also will increases. If volume of the solution is increases, molarity will decreases. How it is changing with temperature, they may ask. Why it is depend on temperature, they may ask. Okay, if they're asking why it is depend on temperature, because this molarity is related to volume. Volume will related to temperature. Temperature is increases, volume of the solution increases. Volume of the solution is increases, molarity will decreases. Understood? Then when comes to molality, this molality is, it is independent of temperature or on temperature. It is independent on temperature. This molality will not change with temperature. Why it is not change with temperature means this molality is related to mass. So mass will not change with temperature. That's why this molality also will not change with temperature. Understood? So they may ask definition of molarity or molality, formula and unit, and it is depend on temperature or not. Okay, then next comes to relationship between this molarity and molality. That means if we know the value of molarity, then we can find out the value of molality. How to find out from molality to molarity, molarity to molality? So for that relation formula is there. If I want molality to molarity, from the value of molality to molarity I want to find out means, then I should use this formula, that is M is equal to MD. MD means molality and density. Then divided by 1 plus molality into molar mass of solute divided by 1000. Okay, this is the formula to find out the value of molarity from molality. Then from the molarity we can find out molality. How to find out? So here also we have formula, that is molality is equal to 1000 into molarity divided by 1000 into density of solution minus molarity into molar mass of solute. Remember, M2 is molar mass of solute. Okay, M means molarity. Small m means molality. D means density. Here also D means density. Small m means molality. Capital M is molarity. M2 is molar mass of solute. Understood? These two relation you should remember. They may ask you. Got it? The next term under this concentration terms, it is third one, mole fraction, will denoted by chi. Okay, so how to define this one? It is defined as the ratio of moles of solute or solvent to total number of moles of solution. Mole fraction is defined as the ratio of moles of solute or solvent to total number of moles of solution. If I write the formula, that molarity, that is mole fraction of solute I want, means solute will represented by 2. If I want solute means that is N2, that is number of moles of solute divided by number of moles of solvent plus number of moles of solute. Okay, if I want to calculate mole fraction of solvent, will represented by 1. For that, number of moles of solvent divided by number of moles of solvent plus number of moles of solute. Okay, then remember the mole fraction of all the component, mole fraction of sum of all the component, like mole fraction of one component plus mole fraction of another component, always equal to 1. Okay, sometimes they will give mole fraction of one component and they'll ask you to find out mole fraction of another component. Remember, this is sum mole fraction of all the components, sum of all the component is equal to 1. Then this one is unitless. There is no unit for this. This is unitless. Okay, and it is also independent of temperature. Okay, why it is independent of temperature? If they'll ask, it depends on moles of solute and solvent. This mole fraction is dependent on moles of solute and solvent. That's why it is independent of temperature. Understood? So these are the important topics under concentration terms, that is molarity, mole fraction. More questions arises from these 3 terms. After that, important points under this concentration terms are, that is first point, if they are giving 10% glucose solution, how we will decode this one is important. 10% of glucose solution means 10 grams of glucose. 10 grams of glucose in 100 grams of solution. Okay, 10 grams of glucose in 100 grams of solution. Otherwise, if they'll give 25% of sodium chloride aqueous solution, means 25 grams of NaCl, that is sodium chloride, in 100 grams of solution, or also we can tell 90 grams of solvent. Sorry, 25 means 75 grams of solvent. Total you should get 100. Okay, solution means which contains solute plus solvent. Solute is 25 means solvent will be 75. Here solvent will be 90 grams of solvent, that is water only. Here also it is aqueous means it is water. Okay, then next point is, remember, 3.62%, that is weight by weight, mass by mass percentage of sodium hypochlorite in water can act as commercial bleaching solution. Commercial bleaching solution. Okay, from this they may ask MCQ. How much percentage of sodium hypochlorite? Okay, this is chlorite. Sodium hypochlorite is used as commercial bleaching powder. Anything, or 3.62% percentage of dash is used as commercial bleaching, or 3.62 of sodium hypochlorite in water can act as what dash. Okay, anything they may ask. Another one important is there is 35% volume by volume. It is ethylene glycol solution can act as antifreeze. That is 35% of ethylene glycol act as antifreeze. Anything they may ask in the MCQ. Okay, remember these 4 points are also important from concentration terms. Okay, so from the concentration terms, what and all you should remember from the concentration terms. First one is molarity, mole fraction. Molarity means number of moles of solute present in 1 liter of solution. Molality means number of moles of solute present in 1 kg of solvent. Okay, formula you should remember, then the unit, then it is depend on temperature, it is not depend on temperature because it is related to volume, this is related to mass. Okay, so if temperature is increases, volume also will increase, molarity will decreases. Then the relationship between molarity and molality is very, very important. Then comes to mole fraction. Mole fraction definition, formula, then this formula, then it is unitless, it is also independent of temperature. Then these 4 points you have to remember from the concentration. Okay, so you got to know all the concept under the concentration terms which are important, right? So based on this topic, how they asked question in PYQs, we'll see. So first question, define the following, that is molarity, molality, mole fraction. I already told definition of these 3 is important. Then next, difference between molarity and molality. For difference, you can write one definition and the formula, unit and temperature. These 4 points you can write for the difference. Okay. Then next, how can we change molality value of solution into molarity value? I already told you relation between molality and molarity is important. 2 formula I gave. So this 2 formula I gave. Correct, no? So this 2 formula is very, very important. What they are asking? They are asking molality value of the solution into molarity. We want molarity. Then this one. Okay, we know the molality value. From the molality, we should find out molarity. So how can you change means you should write this formula. Then next one, calculate the molarity of 9.8% of solution of H2SO4 if the density of the solution is 1.02 grams. So 2 gram per ml and molar weight also they give. First we'll write the given values. Answer for this, how you will write? Given is, so 9.8% means I already told you. So 9.8 gram is mass of solute. Okay, so 9.8% means 9.8 grams of H2SO4 dissolved in 100 grams of solution, which is mass of solution. Then they gave density, that is 1.02 gram per ml, it is density. Then they gave molar weight, that is 98 gram per ml. This is molar weight of solute, that is M2. You know the formula. What to calculate? Molarity. Molarity means capital M is equal to W2 into 1000 divided by M2 into volume in ml. Okay, we know the W2. W2 means mass of solute. Mass of solute value is there. So we want molar. This M2 value also is there. We want V, volume. To calculate volume, what you will do? V is equal to mass by mass of solution divided by density of solution. Mass of solution is 100 divided by density of the solution is 1.02. So how much you will get? Volume, if you do this one, you will get 98.039 ml, because these two are in ml. Okay, then I got the volume in ml. We can apply the value, that is M is equal to W2 value is 9.8 into 1000 divided by M2 value is 98 into 100. So 0 will cancel. You will get answer is 1.02 molar. This is the answer. Okay, understood? Then next question. A solution of glucose in water is labeled as 10%. 10% means 10 grams of glucose in 100 grams of solution. What would be the molality and molarity of the solution and density they gave? Okay, so first we'll find out the molality. How you will find out the molality? Again, fourth one, answer. What you will write? Given. So given is W2. We want, so W2 means mass of solute, that is mass of solute is 10 gram, right? Because it is 10% of glucose solution means 10 grams of glucose it has. Then so then after W2, what you need? W1 I want to calculate molality. Molality I want means I want to calculate. I want W1. W1 value is 90 because 10% means 10 is the mass of solute means remaining is mass of solvent. So 90 gram you will get. Total is 100 gram. Then molar mass, that is W2. W2 how much they gave? They gave 180 gram. Then they gave density. Density of the solution is 1.2. Correct? So then what we want to calculate? We want to calculate first molality, that is small m. Molality formula is W2 into 1000 divided by M2 into W1. So W2 value is 10 into 1000 divided by M2 is 180 into W1 is 90. Okay, so if you cancel all the zeros, you will get value for this one is 0.62 molar. You should write unit as small m for molality, capital M for molarity. Otherwise you can also write gram per mole per gram. Okay. Then next one, we want to calculate molarity. Before going to molarity, to calculate molarity, we want volume. So first we'll find out the volume. Volume of the solution is equal to mass of the solution. Mass of the solution will be 100. Correct? No, full total mass of the solution is total. It is 100. So divided by density of the solution is 1.2. So 100 by 1.2 value, how much? This one we can apply into the formula, that is M molarity is equal to W2 into 1000 divided by M2 into volume in ml. Okay, so W2 value is 10 gram into 1000 divided by M2 value is 180 into 100. This 1.2 will come this side. Okay, so this will get cancelled. If we'll do substitution, you will get 0.67 molar. Okay, we got molality also, we got molarity also. Understood? So by knowing the formula, we can able to find out easily molarity and molality of the solution. Got it? The topic is solubility. So under solubility, important is effect of temperature on solubility of gas in liquid. Okay, so how it will affect. So if it is exothermic process, the reaction is exothermic process, then solubility will decrease with increase in temperature. If it is endothermic, then solubility increases with increase in temperature. More the temperature, more will be the solubility in endothermic condition. More the temperature, less will be the solubility in exothermic. Okay, most probably this dissolution will be in exothermic condition. Then second very important topic is, that is Henry's law. Every year they asked question from this Henry's law. Okay, most repeated topic. Statement is very important. Henry's law statement. State Henry's law. Okay, so if they'll ask state Henry's law, what you will write? It states that the partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in the solution. Mathematically, this mole fraction, partial pressure, is directly proportional to mole fraction. If we remove the proportionality, we will get partial pressure is equal to Kh, that is Henry's constant, into mole fraction. Okay, this one you should remember. So they may ask questions that numerical problem, calculate solubility by giving pressure and Henry's constant. So that time solubility nothing but chi is equal to P by Kh. Okay, questions they may ask from this also. Then next, KH value is very, very important. KH means Henry's constant. This Henry's constant value are different for different gases. For different gases, the KH value will be different. That's why we'll this call as functions of nature of gas. This one will call it as functions of nature of gas, because it have different value for different gases. This KH value is directly proportional to temperature and inversely proportional to solubility. Remember, this point is very, very important. So KH is more, value is in more, then temperature also increases, then solubility will decreases. Okay, sometimes they will ask question from this two gas. Gas A is more soluble than gas B, then which gas have more KH value? Okay, gas A is more soluble than gas B. Okay, then which have more KH value? More KH value means less solubility. Less solubility is therefore B. So more KH value is for B gas. Understood? Like this kind of question they may ask. They may give KH value, then they'll ask you to which have more solubility. Otherwise, they will give solubility, then they'll ask you to find out which have more KH value. Okay. Then next, under this important question may arise from, that is aquatic species are more comfortable in cold water rather than hot water. Aquatic species are more comfortable in cold water rather than hot water. So what you will write? More the temperature, less will be the solubility of oxygen in water. Okay, more the temperature, less solubility of oxygen in water. So in hot water, amount of oxygen is less. So aquatic species are not comfortable in hot water. It is comfortable in cold water. Okay. Then next one, applications of Henry's law are very, very important. Next topic is application of Henry's law. In that, first one is to increase the solubility of carbon dioxide in soda water. The bottle is sealed under the high pressure. So they'll ask, write any one or two applications of Henry's law. They will ask. So that time you can write this first point. So then next one is to avoid toxic effect of high concentration of nitrogen gas in the blood. The tank used by scuba divers are filled with air diluted with helium. So scuba divers, they will go under the sea. That time pressure will be high. So at high pressure, nitrogen gas which is present in this tank will dissolve into the blood of the scuba divers. If it is dissolved into the blood of the scuba divers, after they'll come up that time the pressure will be very low. When pressure is low, that time which nitrogen gas is already dissolved in the blood, that one will come out of the blood. Okay, so that time it is coming out of the blood means in the blood nitrogen gas will be there. Whenever it is there, that time that condition will call it as bends. Okay, bends means it is a painful, dangerous medical condition in deep sea divers caused by nitrogen bubbles forming in the blood, which is dissolved underwater. This nitrogen gas is dissolved in the blood, that will come out of the blood and form a nitrogen bubbles. That condition will call it as bends. To avoid this condition, we are diluting helium to that tank. Okay, helium is 11.7%, nitrogen gas is 56.2%, oxygen is 32.1%. In this ratio, then add the gases. Okay, so this is also one of the applications of Henry's law. Then third one is at high altitudes, low blood oxygen will be there. Okay, the people who are living at high altitudes, they'll have low blood oxygen because the climbers also, because their pressure is very low. So low pressure and temperature also very low. That time this oxygen will not dissolve into the blood. Okay, so that time what they will get, these climbers and people who are living at high altitude will become weak and make them unable to think clearly. Okay, this condition, this system, will call it as anoxia. They may ask what is anoxia also, they may ask what is bends also. Got it? These three applications are very, very important. They'll ask any one of these. Okay, then next we'll see questions from this solubility and Henry's law and application, how the questions will arise, is that PYQ questions are there here. So okay, next one is PYQs from this solubility and Henry's law. First question is, low concentration of oxygen in the blood and tissues of people living at high altitude is due to, why? Can you tell me? So what will happen? I already told you, at high altitude, the partial pressure of the oxygen, at high altitude, partial pressure of the oxygen will be very low. That means atmospheric pressure is very low. That's why the oxygen will not dissolve in the blood and tissue. Okay, so if they are asking low concentration of oxygen in the blood due to the low atmospheric pressure at high altitude. Okay, then next one is, an unknown gas X is dissolved in water at 2.5 bar pressure and has mole fraction is equal to 0.04 in the solution. The mole fraction of X gas when the pressure of the gas is doubled at the same temperature, they are asking. So first one they are telling, this X gas is dissolved in the 2.5 pressure bar. So we'll apply the Henry's law here. What is that Henry's law? That is P is directly proportional to P is equals to KH mole fraction. Okay, pressure is equal to KH, Henry's constant, into mole fraction. Pressure they gave, that is 2.5 bar, and KH we don't have, then mole fraction is 0.04. First we'll find out the K value. So KH is equal to, how much you will get KH value, that is 2.5 by 0.04, you will get 62.5 bar. Okay, so this is KH value. Then they are asking for the same gas X, if the pressure is doubled, then what is the mole fraction? Pressure is doubled means, first one is 2.5 means it is doubled means pressure will become 5. Okay. Then when the pressure is double, that time they are asking mole fraction. KH value we got to know, that is 62.5. Then I should find out the mole fraction. Okay. So easily we can find out the mole fraction. So if you substitute, what you will get? Mole fraction, you will get 0.08. Okay. Understood? Like this you should find out. Then next one, why aquatic animals are more comfortable in cold water than warm water. I already told. So if temperature is increases, solubility of oxygen will decreases in water. So in a hot water, amount of oxygen is very less. So in hot water it is not comfortable. In cold water, aquatic animals are more comfortable. Okay. Then next question, gas A is more soluble in water than gas B, which has more KH value. We already know KH value is inversely proportional to solubility. Then more KH value means less soluble. Which is less soluble? Gas B is less soluble. So this gas B have more KH value. Okay. Then state Henry's law. I already told statement is important, and give one application. They may ask one application also, two applications also. Then why air is diluted with helium in tank of scuba diver. I already told while explaining the application. What is that? To avoid the toxic effect of high concentration of nitrogen gas in the blood, scuba divers will dilute the helium gas. Okay. Then next problems they asked, calculate the solubility of carbon dioxide in water at 298 Kelvin under 760 pressure, that is mmHg. Okay. So how you will calculate this formula also I give. If I want to calculate the solubility of carbon dioxide means, that is pressure by KH. Formula is pressure by KH. So pressure how much they gave? 760. KH value is 1.25 into 10 to the power of 6. If you calculate this one, you will get 6.08 into 10 to the power of minus 4. Okay. Then next, give reason. At high altitude, people suffer from anoxia, resulting in the inability to think. Okay. As I told, same. This one you can write the answer. Okay. At high altitude, pressure is very low. At low pressure, blood oxygen is very less in our blood. So it will cause anoxia. Okay. Understood how they will ask questions? Got it? Then next important topic is Rawls law. Next important one is Rawls law. So this one also they will ask statement. Okay. What you will write for the statement? It states that for a solution of volatile liquids, the partial pressure of each components in the solution is directly proportional to its mole fraction. Okay, this is the statement which is important. Rawls law, it states that for a solution of volatile liquid means which will ready to evaporate. For the solution of volatile liquids, the partial pressure of each component in the solution is directly proportional to its mole fraction. Mathematically, P, that partial pressure, is directly proportional to mole fraction. Okay. So if I'll remove the proportionality here, we'll get partial pressure is equal to partial pressure of pure solvent into chi. Okay, so this is the mathematical expression for Rawls law. P naught is equal to partial pressure of pure solvent. Pressure of pure solvent. Okay, then another important point under this concept is, so whenever we are adding non-volatile solute to the volatile liquid, the partial pressure. So if I am taking a container, in this container there is a volatile liquid, volatile solvent. Just imagine it contains volatile solvent. For this volatile solvent, I will add non-volatile solute particle. For the volatile solute, volatile means which one means ready to evaporate. Which one will evaporate? That one will call it as volatile solvent. For this volatile solvent, if I'll add non-volatile solute, then the partial pressure is due to only volatile component. Okay, because this one will not evaporate. It is not evaporating means it will not create any vapor pressure. Understood? So vapor pressure, that partial pressure is only due to volatile solvent. Okay, that one you should understand. So this pressure is only equal to partial pressure of volatile liquid means, that is pure solvent means total, P total, that means total pressure is equal to pressure of solvent. Okay, remember, whenever we are adding non-volatile solute to volatile solvent, then the partial pressure is depend on the volatile solvent. Okay, then another thing here, if you add non-volatile solute to volatile solvent, then the vapor pressure will decreases. What will happen? Vapor pressure will decrease when non-volatile solute added to volatile solvent. Okay, the next point is important, that is, if liquid with low boiling point will have high vapor pressure, which one will evaporate first? Which liquid have low boiling point? Which have low boiling point, that one will have high vapor pressure. Okay, and that one will vaporize first. Then next one, which solutions obeys Rawls law? Which solution obeys Rawls law? That solution will call it as ideal solution. Which solution obeys Rawls law? We'll call it as ideal solution. Okay, at all the concentration it should obey the Rawls law. That time that one will call it as ideal solution. Then other one, you can see here, this is what Rawls law expression. If you'll observe the Henry's law expression, if you'll recall the Henry's law mathematical expression, how you will write Henry's law mathematical expression? That is P is equal to KH into mole fraction. If you see these two, almost similar only, no? For both the condition, the partial pressure is directly proportional to mole fraction only. Only the difference between the constant. Okay. So, they may ask similarities between Henry's and Rawls law. Okay. Or difference between Henry's law and Rawls law. If they are asking similarities between Henry's and Rawls law, what you will write? Similarities. So, both Henry's and Rawls law state that the partial pressure of a component in a solution is directly proportional to its mole fraction. Okay, so similarity between Henry's law and Rawls law both states that the partial pressure of a component in a solution is directly proportional to its mole fraction. Then another one, they'll ask difference also. Difference between Henry's law and Rawls law. So here what you will write? So Henry's law and Rawls law, in case of Henry's law, you will write applies Rawls law applies to volatile component of solution. Then Henry's law applies to gas dissolves in liquid solution. Understood? So first difference, if they are asking, you can write in Rawls law it applies to volatile component of solution. This Henry's law will apply for gas dissolved in the liquid solution. Another difference you can give that mathematical expression. Here partial pressure is equal to partial pressure of pure solvent into mole fraction. In case of Henry's law, partial pressure is equal to Henry's constant into mole fraction. These two difference you can write. Okay. Under the Rawls law, statement is very, very important. Then the mathematical expression. Then what will happen when non-volatile solute is added to the volatile solvent? So vapor pressure will decreases. Then total pressure is directly proportional to solvent. Okay. Then liquid have low boiling point. Which liquid have low boiling point? That one will have high vapor pressure. Then which solution obeys Rawls law? Will call it as ideal solution. Then similarities between Henry's and Rawls law, difference between Henry's and Rawls law. These things are very, very important for your examination. Okay, now we'll discuss PYQ questions from Rawls law. First question is identify which liquid will have higher vapor pressure at 90 degrees Celsius if the boiling point of two liquid A and B are 140 degree and 180 degrees Celsius respectively they gave. Okay, they are asking which have high vapor pressure. Okay, I already told. So the liquids which have low boiling point. Liquid which have low boiling point will have high vapor pressure. Okay, this point I already discussed. Okay, so according to this point, which have low boiling point, this have low boiling point, that is A have low boiling point, so A have high vapor pressure. Understood? Then next, define Rawls law or state Rawls law. I already told you, they'll ask state Rawls law, I already gave. Then what is the similarity between Rawls law and Henry's law? I told you. They may also ask difference between these two. Then name the solution which follows Rawls law at all concentration and temperature. Which solution will follow Rawls law? You people know, right? That is ideal solution. Okay. Then which formula represent Rawls law for solution containing non-volatile solute? I already discussed this one. Yes or no? So if solution have volatile solute solvent and non-volatile solute means, then which one will relate? So first one, if we'll take partial pressure of solute. Solute is non-volatile means it will not create partial pressure. So first one is wrong. Second one is, this is related to Henry's law. So this is not related to Rawls law. Then comes to third one. So total partial pressure is equal to partial pressure of solvent. Correct? No? I already told. If solute is non-volatile means solvent is volatile. So total pressure will equal to partial pressure of solvent. So this is the correct answer. C is the correct answer for fifth question. Understood? Next topic is ideal and non-ideal solution. Okay, this one also very, very important. Ideal solution, non-ideal solution. Okay, so they may ask definition of these two. Define ideal solution or define non-ideal solution. If they are asking define definition, you can write the solution which obeys Rawls law for all concentration. Okay, then for non-ideal solution, the solution which does not obeys Rawls law for all concentration. Okay, this is the definition for ideal and non-ideal. And also they may ask give the difference between ideal and non-ideal solution. For that, second point difference is that is delta mix H. That means after mixing solute and solvent, what will happen? The energy, how much energy will change, that is equal to 0 in case of ideal solution. The next one, delta mix V, that is volume. Change in volume after mixing solute and solvent will be 0 in case of ideal solution. But in case of non-ideal solution, this delta H is not equal to 0 and delta V also is not equal to 0 for non-ideal solution. After mixing, energy also will differ, volume also will differ. Okay, then another point what we can write means interaction. Okay, interaction of solute and solvent is same as solute solvent. Okay, before mixing, solute-solute interaction will be there. Force of attraction between solute-solute, force of attraction between solvent-solvent. What is there? Force of attraction, same solute and solvent also will have. Okay, but in case of non-ideal solution, not same. You can write completely. Interaction of solute-solute and solvent-solvent is not same as solute and solvent. Okay, the very important, they may also ask you give example for ideal solution, otherwise they only can give any example. You should identify it is ideal or non-ideal. For ideal solution, example is mixture of methanol and ethanol, mixture of methanol and ethanol, or N-hexane and N-heptane. Other example is benzene and toluene. Okay, methanol or ethanol, hexane or heptane, benzene and toluene. So these three are the example for ideal solution. You can see same functional groups are there in both the molecules. Okay, then next examples for non-ideal solution means we'll discuss this non-ideal solution will again classify into two types, that is one is positive deviation, negative deviation. There are two types are there under non-ideal solution. For this I will give example, that example only you can consider for non-ideal solution. Okay, so these two also very important. What is that? Non-ideally under next under the non-ideal solution we have two types. One is non-ideal solution with positive deviation from Rolle's law, positive deviation. Then the one non-ideal solution with negative deviation from Rolle's law. There are two category. Okay, under the non-ideal solution. So these two also very important. They may ask these two difference between these two and example for these two they will ask. If they are asking difference between these two, you can write first one, that is delta mix H. Delta H after mixing it will be more than 0. That means positive value you will get. Remember, for positive deviation the value will be, delta H value will be positive. Then second one, delta V after mixing volume also will be more than 0. Then volume also will get positive value for positive deviation. Okay, when comes to non-ideal solution, delta H mix is less than 0. Less than 0 means you will get negative values. Then second one, delta mix V is less than 0. So this one also you will get negative values. Okay, then third one, the force between two, that is force between A, B is less than force between A and A. Force of attraction between A and force of attraction between B and B. That means A and B means solvent and solvent, solute and solute. This force is more compared to AB, solute and solvent. Okay, when comes to negative deviation, the force between solute and solvent is more than force between solute and force between solvent and solvent. Okay, then another one also you can write, that is P total, that is total partial pressure is equal to, is not equal, it is greater than partial pressure of A plus partial pressure of B. Here fourth one, total partial pressure is less than partial pressure of A plus partial pressure of B. Okay, this one also you can write. Then examples are very, very important. So that is, examples are, example for positive deviations are ethyl alcohol. Okay, ethanol also you can write ethyl alcohol plus water, or acetone plus carbon disulfide, or chloroform with benzene, or acetone and benzene, or ethanol and acetone. Any one they will ask question from this example. Okay, so if ethanol and acetone are mixing, which deviation it will take, you can tell it is positive deviation. Then example for non-ideal solution, that is HNO3, nitric acid in water, then chloroform in acetone, or acetic acid in pyridine, HCl hydrochloric acid in water, phenol in aniline. Okay, these are example, very, very important. You have to remember these things. Okay, so this is very, very important. Then we'll discuss the PYQ questions. Before going to PYQ question, other topics also I will tell you, that is azeotrophs. This one also very, very important topic. Azeotrophs, definition of azeotrophs they will ask. So what is definition of azeotrophs? Azeotrophs are binary mixtures that having same composition in liquid and vapor phase, and boil at constant temperature. Okay, so azeotrophs means binary mixture. Binary mixture means the mixture which contain only two component. Okay, that matlab that solution. Okay, the solution which has same composition in liquid and vapor phase. If it is in liquid also, if it is in vapor phase also, in both the phase, if it have same composition and it will boil at constant temperature, that solution will call it as azeotrophs. Okay, they are azeotropic mixture. That one also we can tell. These azeotrophs have two types. That one also important. First one is minimum boiling azeotrophs. Second one, maximum boiling azeotrophs. First, we'll learn about minimum boiling azeotrophs. Minimum boiling azeotrophs means the non-ideal solution, which shows positive deviation from Rolle's law. Okay, from the Rolle's law, which will show the positive deviation, that one we'll call it as minimum boiling azeotrophs. Remember, we already studied here difference between positive. This one also call it as minimum boiling azeotrophs. Example here only is there. That one also you can take. Okay, so this minimum boiling azeotrophs, under this another point you should remember, that is binary mixture boiling point less than its two components. That means after mixing, that boiling point is very less compared to the two component. Okay, solute and solvent, two component will be there. Before mixing, if we'll separate solute and solvent, that pure state have more boiling point compared to this solution. You should remember this one also. Example is 94.5% of ethanol and 4.5% of water by volume. Okay, then second example is maximum boiling azeotrophs. Minimum boiling azeotrophs and maximum boiling azeotrophs. Maximum boiling azeotrophs means the non-ideal solutions which shows negative deviation. Maximum means negative, minimum means positive. Remember that one. Okay, negative deviation from Rolle's law. Okay, then this, under this you should remember, that is binary mixture. Binary mixture's boiling point is more than its component, more than its two component. Ulta of minimum boiling azeotrophs. Okay, there less than, here more than its two components. Then examples, 68% of HNO3, then and 32% of water by mass. Okay, here you will take ethanol, here you will take HNO3. So these two are example of maximum and minimum boiling azeotrophs, which are very, very important. Understood? Then we'll discuss PYQ questions from these topics. Okay. Now we'll start with the PYQs from the ideal and non-ideal solution and azeotrophs. So first question, which of the following pair forms an ideal solution? Which one will form ideal solution? Okay, so we can see I already gave for ideal solution example and non-ideal solution example. So here chloroform and acetone is not ideal, and ethanol acetone also is not ideal. N-hexane and N-heptane, same functional group is there, no? So this is called ideal solution. Okay, so that's why I told you examples are very, very important. You should remember all the examples. Then define ideal solution. You should define which solution will obey Rawls law, that is called ideal solution. Then difference between ideal and non-ideal solution is important. I already taught you. Then comes to problem. There is 30 grams of urea is dissolved in 846 grams of water. Calculate the vapor pressure of water for this solution if vapor pressure of pure solvent is 23.8. Okay, so what they're asking vapor pressure of pure solvent. So we know according to the Rawls law, what is the formula? P is partial pressure of water is equals to partial pressure of water at pure form into mole fraction. Okay, into mole fraction of water molecule. After adding into the solution, the solution where partial pressure, also we call it as partial pressure of water. So this partial pressure of water, we already know pure form of partial pressure. It is pure water. Vapor pressure is 23.8. So P naught is 23.8. Then mole fraction of water I should find out. So how to find out mole fraction of water? Mole fraction of water is equal to number of moles of water divided by number of moles of water plus number of moles of, here which one is there? Urea. Okay, so if we'll do number of moles of water, first we'll find out the number of moles of water. So number of moles of water, how to find out? Given mass divided by molar mass. Given mass is 846, molar mass is 18. Molar mass of water is 18. If we'll do the calculation, you will get 47. Then number of moles of urea. Urea given mass is 30 divided by molecular mass is 60. So if we'll do, you will get 0.5. So if you'll apply these two values into this formula, so what you will get? You can calculate. If you'll apply to this formula, you will get 0.99. Okay, we got the mole fraction of water. That one we can apply here. That is 23.8 into 0.99. So we'll get 223.5 mmHg. So this is the vapor pressure of water. Got it? Then next question, on mixing 20 ml of acetone with 30 ml of chloroform, total volume of the solution is. First check this acetone and chloroform is which deviation it will take place, undergo. Okay, acetone and chloroform means, so which one example under which it will come? Acetone and chloroform, here only you can see. Okay, chloroform and acetone, here it is there. Which deviation it will take place? It will take place negative deviation. Negative deviation means on mixing we'll get a negative value. Negative value means less value we will get. Understood? So here if we'll add 20 plus 30, we should get 50, but because it is negative deviation, we'll get less than 50. So option A is correct. Got it? Then next question. What happens when acetone is added to the pure ethanol? Then check again, you check acetone and ethanol, which deviation will take place? Acetone and ethanol, here it is there. Acetone and ethanol will undergo positive deviation. So what you will write for that? So mixture of ethanol and acetone shows positive deviation from Rawls law. When acetone is added to ethanol, it will form a hydrogen bond. Okay. That's why what will happen? It will show a positive deviation and it will form hydrogen bond between ethanol and acetone. Got it? Then also you can write when acetone. So next question is, what happen when acetone is added to pure ethanol? So what will happen if we add to pure ethanol? This acetone and ethanol is example for positive deviation. You should tell this one will show positive deviation. That means more value we will get. So why it is getting more value? This acetones will break the hydrogen bond which present in ethanol. Between ethanol, there is a hydrogen bond. This hydrogen bond, this acetone will break. Due to that, the vapor pressure of the solution will increases. Okay, like that you should write. Then next question is, what type of deviation forms from Raoult's law is observed by mixing chloroform and acetone, or ethanol or acetone? Ethanol, acetone, before only we study, that is positive deviation. So chloroform and acetone means you can see, check. Chloroform and acetone is example for negative deviation. You can write negative deviation forms from the Raoult's law is observed. Okay. Then why is a decrease in vapor pressure observed in mixing of chloroform and acetone? So why it is getting? Again, chloroform and acetone only. Why vapor pressure is decreases? Because it is showing negative deviation. So negative deviation means, here what will happen means, chloroform molecule is able to form a hydrogen bond with acetone. This chloroform and acetone both will form hydrogen bond. When both will form a hydrogen bond, escapable tendency of the molecules of each component will be less. So vapor pressure also will decreases. So it will show negative deviation. Understood? What will happen? Chloroform is reacting with acetone means chloroform will form a hydrogen bond with acetone. So these two are forming a hydrogen bond means bond force of attraction is very strong. So escapable tendency of the molecule of each component will be decreases. So vapor pressure also will decreases. So it will form a negative deviation. Like that you should write. Then write two difference between ideal solution and non-ideal solution. You can write. Then what is meant by positive deviation from Raoult's law? Give an example. You can write now what is meant by positive deviation. I already gave in that. You can refer that one example also. What is the sign of delta mix? Positive means positive value. Negative they are asking means negative value. Just write negative or positive by checking the which deviation it is. Then next question is, on mixing liquid X and liquid Y, volume of the resulting solution decreases. They are taking X and liquid X and liquid Y. Both they are mixing. Then after mixing, the volume they are getting less. Okay. What type of deviation forms Raoult's law? From Raoult's law is shown by the resulting solution. Can you tell me what form it will show? So what will form? Volume is less means, where volume will less, in which volume will be less? So if you're adding liquid X and liquid Y, volume will become less. Volume is less means it will show negative deviation. You should write it will show negative deviation. So it is showing negative deviation means temperature will increases here. Okay. What type of deviation is negative deviation? Then what change in temperature? Temperature will be more. Temperature will increases. Temperature increases after mixing X and Y. Okay. Then next one is an azeotropic solution of two liquid has boiling point lower than either of the two when it will show like this. I already gave azeotropes maximum and minimum boiling point. Here I told binary mixture boiling point is less than its two component in minimum. Binary mixture boiling point is more than its two component in maximum. Here what they are telling, solution means it is binary mixture. This solution of two liquid has boiling point less than two component. Less than two component means where it will come? Less than its two component means it is minimum boiling. Minimum boiling means it will show positive deviation. Understood? Then define azeotropes. You can write the definition. What type of azeotropes will form negative deviation? It is maximum. Negative means maximum. Positive means minimum. Example, you can give one. Okay. So this kind of questions